Theorem 9.1 Parallelograms on the same base and between the same parallels are equal in area.
So we have our theorem 9.1. Parallelograms on the same base and between the same parallels are equal in area. Now, here you can see that you have two parallelograms, parallelogram A, B, C, D and parallelogram E, F, C, D. So we have two parallelograms, okay, which lie on the same base DC, and both these two parallelograms lie between the same parallels, parallel AF and BC. AF and BC are the same parallel lines, and BC is the base on which we have two parallelograms, parallelogram A, B, C, D and parallelogram E, F, C, D. So these things are written in the given. Next, what you need to prove is that you have to prove that area of parallelogram A, B, C, D and the area of parallelogram E, F, C, D must be equal. Now, how can you prove that the area of the parallelogram A, B, C, D and the parallelogram E, F, C, D are equal? Now, let us consider these two triangles. Triangle A, D, E and triangle B, C, F. Let us prove that these two triangles are congruent. So we will write in triangle ABE and triangle BCF. Okay? So we need three conditions to prove that the two triangles are congruent. So first condition, if you observe properly, since A, B, C, D is a parallelogram, so AB and BC are two parallel lines. Okay? And AF is the transversal. So angle EAD and angle FBC both are equal to each other. You can see these two are parallel lines. AD, BC, okay, these two are parallel lines, and AF is the transversal. So we can say that these two angles are corresponding angles and they are equal. So we can write angle, okay, we can write angle EAD equal to angle FBC. We can write here corresponding angles. Next, the second condition. Now, next you can see that EFCD is also a parallelogram. So, definitely the opposite sides are parallel. You can see that ED and FC are parallel to each other and AF is the transversal. So we can consider angle AED and angle BFC are also equal. They are also the corresponding angles. You can see this is ED and this is FC. Okay, they are both parallel to each other and this is the transversal AF. So these two angles are also equal to each other because they form corresponding angles. And we know that corresponding angles are equal. So we can write the second condition. Angle AEB is equal to angle BFC. Corresponding we can write here corresponding equation 1. Third condition, we can take ED parallel to FC. ED parallel or equal, we can write ED equal to FC. We can write ED equal to FC because FEFCD is a parallelogram, and we know that opposite sides of a parallelogram are equal. So we can consider ED equal to FC. Opposite sides of a parallelogram is equal. Okay, so we got three conditions. Therefore we can say that triangle ADE is congruent to triangle BCF. Now, which criteria are we going to use? We are going to use the angle side criteria. Angle side. Okay, angle side criteria. So we can say that both the triangle are congruent to each other. Now we know that congruent figures have the area of congruent figures are equal to each other. So we can write here, which implies area of triangle ADE equal to area of triangle BCF. And the reason we write, since congruent figures have equal areas. So we can mark it as equation number 1. Now I have roughed this part. Okay, let's continue. Now here what we have to do, we'll write therefore area of parallelogram ABCD equal to. So area of parallelogram ABCD can be written as area of the triangle AED, area of the triangle AED plus area of EBCD. Area of AED, the area of triangle AED plus area of EBCD. Now, according to equation number 1, area of triangle AED or ADE, same thing. Whether we write ADE or AED, same thing. Okay, both shows equal. Whether we read it like this or whether we read it like this, same thing. So here you can see from equation 1 that area of triangle ADE and area of triangle BCF are equal. So instead of ADE, let us write from equation 1 BCF plus area of EBCD. Now here we can write the reason from equation 1. We change this. Now area of triangle BCF, this is the triangle BCF, and area of EBCD. Okay, so if we add up this triangle and EBCD, this part, then what will we get? We will get the full parallelogram EFCD. So area of parallelogram EFCD. So hence we got that area of ABCD, area of parallelogram ABCD is equal to area of parallelogram EFCD. Hence we got the area of the two parallelograms on the same base CD equal.